Hello everyone, welcome to the course on data structures and algorithm. In this particular video we are going to see how to implement queues using linked list. We have already seen the simple queue in our previous video, so if you have not referred, I would recommend you to refer the previous video on simple queues. In this one we are going to implement it using linked list. In our previous case we implemented it using arrays. So now we are not going to use arrays, we are going to use linked list for the implementation of queue. Now if we simply compare the queue, the normal queue. So normal queue is, it looks something like this. The person who comes first, supposing this lady has come first, so she'll be served first. So the person comes first, gets out first. Alright, the person, this guy came after this lady, so he is at second position, then this guy is at third position, then fourth position, then fifth position. So you can see that insertion or adding into this queue is happening from one end, which is called the rear end, or sometimes they call it tail end. And deletion means once the data item, in this case suppose the person is served, the person will be removed from this queue. So that is done from other end, which is nothing but my front end. Sometimes you call it head end. So we will be using word front and rear very often, but you can always use head or tail instead. Alright, so now let us try to see how can we do this using linked list. So you know that in case of linked list the structure is something like this. The very first node is, supposing this one is my first node, so it is having the value 10. So I will be storing the first node's value over here and I call it the pointer front. And then just the second person, when the second person comes, it will be after 20. So after 10. So this 10 will be pointing to the second person, which is nothing but 20. Supposing the 30, so 30 will come after 20, so 30 will come after 20. Let's say this one is 40, this one is 50, so 40 and 50. And so the thing is, this lady is at the front position. So front pointer is pointing to this 10 and this lady is at the rear position. Alright, so rear pointer is pointing to this one. So over here you consider this as a 50. So this one is the rear pointer. Alright, so front pointer is pointing to 10 and rear pointer is pointing to 50. Now if there is an insertion means if new person comes to this one, then in that case it will be inserted. The person comes from the rear end, so the person will be over here after this lady. Alright, or supposing this 50, it will be 60 for example. But if we make deletion, then deletion will be done from front. So deletion will be done from front. The node you are going to delete from the front side, the node you are going to add will be from the rear side. So this is the only thing that a student needs to remember. Deletion will be done from front end and we call it DQ. The function that we call it DQ, deletion from the queue, and insertion we call it NQ, entry into the queue, that is insertion. Alright, so with this basic explanation, let's move further. So let us try to implement this using programming language. So we are going to have a node structure with two members. One is a data and other is a pointer. So every node will be having two members, a data member and the next is nothing but the pointer which is pointing to the next node. Right, and these could be anything. You can have any node name like new node or something like this, and it can have address also, let's say 1000. So the data will be put in this one, let's say 10. The address of next node will be put, for example the next node address is 2000, so that 2000 will be put over here. That means now this is pointing to this node, and this node is again having data as one member and next as another member. You can have other values like 20 over here and address of third node, let's say 3000. So you can store that over here saying that second node is pointing to third node, something like this. So this is the structure composition of this particular node. Now as we have discussed, we are going to have two pointers, front pointer and rear pointer. Front pointer is nothing but pointing to the node which is in the beginning, which came first. So front pointer is nothing but, for example, in this case 10 came first, then 20, then 30, then last 40 came. So in this case the front is pointing to 10, and because the last was 40, so you can say this is my rear end. Alright, but initially when there is no element in the list, so we call it list empty. So when the list is empty, the front and rear both pointers are set to 0. So when front and rear both are 0, we call it the list is empty. Now let us insert element into, and insertion, as we have just discussed, it is called enqueue function. So in enqueue, first we create a new node. So we create a new node. This malloc function we have already discussed during our linked list implementation. So if you are unaware of this malloc function, I would recommend you to go through those linked list videos. So struct node star new node. So a new node is created over here, and of course it is having two member, data member and the next pointer. So I am having a data member and the next pointer, and let us assume that the address of this one is 1000, for example. Then I am passing something to this. For example, I am passing 10, means I wish to create a node having data 10. So that data item 10 is inserted into new node arrow data. So this one is new node arrow data. So I am going to put 10 over here, and then new node arrow next is null. This new node arrow next, that I set it to null. That's it. Then I'm checking with front and rear equal to null. So which is this condition? Front equal to null and rear equal to null. That means there is not a single data element in the list. That means the list is empty. If the list is empty, this is going to be the very first node in the list. So in that case, front and rear both should be pointing to new node. So front is also this one and rear is also this one. So this is the case having only one element in the list. So that means front is the same one and rear is also pointing to the same node. Alright, so this if condition will be executed only once. Alright, now onwards this condition, this if will not be executed, because front and rear now they are 1000, 1000, they are no more null. Now let us try to execute this code one more time, and let us try to see that what is happening. So now next time when I call this function again, for example, now I am calling this again, and let me use another color. So for example, I am using blue. So if I am calling this again with item 20, so again this new node will be created. So again a new node is created. This is nothing but my new node. The address you can assume anything like 2000, and then this data item 20, I am going to put it in new node arrow data. So 20 I am going, because this is my data and this is my next. So new node arrow data equal to 20 and new node arrow next equal to null. So new node arrow next equal to null. So this is done. Now I am checking front equal to null and rear equal to null. So I know that this condition has already happened, so it is not going to happen again. So I am just erasing it. So next time I will be having in rear only. So in rear I am having two steps. Rear arrow next equal to new node. What is rear? Rear is this 1000. Arrow next equal to new node. What is new node? 2000. So that 2000 I am going to put it in rear arrow next. So now I am going to put this 2000 over here. So the moment I put 2000, now I can erase this null, and now that means this is pointing to this second node. Alright, because 2000 means it is pointing to this node. This is my first step. This is my first step, and second step is, now because this second node has been added, so I will be moving this rear also. So now rear should not be pointing to 10, it should be pointing to 20. So this rear equal to new node. So new node equal to 2000. 2000 is assigned into rear. So now the new value of rear is 2000. That means it is pointing to this 20. So now I can erase. Now I can erase this rear from here. Alright. Now let us do this whole operation one more time, and let us add one more node over here. So this time let me use another color. Let's say I'm using green color. So now let us try to do it with the third one. So third time, suppose I am calling this function with item equal to 30. So now again new node will be created. So a new node has been created. Alright, and the address, you can assume that it is 3000, and it has got two member, data member and next member as usual. And because now this is new node, we can always erase the earlier new node that we created. Alright, so that has been erased. Now the thing is, this 30 data item 30 is put in new node arrow data. So this is my new node arrow data. So now this is 30, and null is placed in this new node arrow next. So new node arrow next is equal to, now this is null. So this new node has been created. Now if front equal to null and rear equal to null, we know that this is not going to happen, because this will only happen when there is not a single node. And we can see that in our list already two nodes are there. So we will move into this else part. In else part, the first statement is new node arrow rear arrow next equal to new node. So what is the value of new node? 3000. So that 3000 I am going to put it in rear arrow next. So where is rear? Rear is over here. Where is its next? Next is over here. So I am going to put 3000 over here. That means earlier it was null, now it is having 3000 value. And the moment I put 3000 in it, that means I can say now this is pointing to this. So this is my first statement. And second statement is this one. New node value is assigned into rear. So new node is 3000, that is assigned into rear. So earlier rear was 2000. Now the new value of rear is equal to 3000. That means the rear is pointing to the third node. So the rear is pointing to third node. So I can erase the previous value of rear from this one. Alright, so this is the situation. So likewise you can keep on moving with different values. 10 has been inserted, 20 has been inserted, 30 has been inserted. You can even insert 40 and everything. But you can see that front has been set at the very first location and rear has been set in the last location. This is something what we are going to use later on. So this is very important. So if I draw this in a very simple terminology, it would look something like this. If I make it very simple one, I am having front node, first node being pointed by front, last node being pointed by rear. Alright, and the first node is pointing to second node is pointing to third node, and that's it. You can always put some value if you want, 10, 20, 30, no problem. Even if you want to have more clarity, put some addresses over here for the sake of example. Alright, and you can see that this 2000 has been placed here, that means it is pointing, this 3000 has been placed here, that means it is pointing to likewise, and this one is null. So this is the same linked list, but all you need to remember is the front and rear, because we will be playing with this pointer in our DQ part. So now let us move further in our next slide. So we will be seeing DQ. So DQ is nothing but deletion from the queue. So if you have the queue already ready, alright, if you have the queue already ready, for example, we are having, say, let's say 4 nodes, alright, and let's put some values 10, 20, 30 and 40. Alright, and then 10 is pointing to 20, 20 is pointing to 30, 30 is pointing to 40, and this is null. And now this is my front pointer, and now this is my rear pointer. You can put it rear pointer over here or maybe over here. Alright, so now we are going to create a temporary pointer, which will be, because we wish to delete the very first one, so at the end we will be deleting. All right. So if front equal to null, so this is the situation when there is not a single node. So we know that if the list is empty, if the queue is empty, the front and rear both are null. So you can check anyone. For example, in this case, is front equal to null, then queue is empty. So there is no point in deleting anything, because if the queue is not having single element, what are you going to delete? Nothing. All right. So but what if the front is not null? So in this case, I wish to delete this. So first I need to move this front. So first work is I will be moving front equal to front arrow next. So front will be over here. So now this front has been moved, and once the front has been moved, now what next? The next part is to remove this temp. So for that the function is free. So the moment you use free temp, what will happen? This node will be deleted. The node will be deleted from the memory, and memory will be released. So this is the situation after this second function, second statement, free temp. So just by these two statements you can see that the very first node has been removed and front has been moved to next one. So this is the second one, DQ. We have already seen insertion, that is NQ, and this is DQ. Now suppose PIP. So PIP is nothing but you are not going to delete anything, but you are just going to print the values of front and rear. That's it. You don't want to change anything. So in this case, the simple thing is we are going to print front arrow data. Suppose this one is front, and suppose you have put 10 over here, so it will be printing 10. And suppose this one is rear, all right, and you have put, let's say, 40 over here, so it is going to put 40, print 40. And this is the simple stuff as we have seen, 20 pointing to 30, 30 pointing to 40. So it doesn't care about the rest of the element, it only prints the front and the last element. And we don't move anything, we don't do front equal to front arrow next, we don't do rear equal to something, nothing. Whatever is there, we are going to keep it just to printf. And that is again only when the front is not null, means if the queue is empty. If the queue is empty, then you are not going to do this one. But if the queue is not empty, we are going to print front and rear. And last is display. So in queue you always start printing from the very first node. Alright, and supposing you are having these 4 nodes, and the very first node, as we know, it is being pointed by a pointer called front. Let's say it is having 10, 10 is pointing to 20, 20 is pointing to 30, 30 is pointing to 40, and 40 is not pointing anywhere, so it is null. And this is my rear. So what you will do, you will start from this position. So we don't want the front to be moved, so we will be taking one temporary pointer, and the value of front is assigned into that temporary. So temporary is pointing to this, and then we will be printing temp arrow data. So temp arrow data is 10, and then we will be moving temp equal to temp arrow next. So next time temp is over here. So then again temp arrow data means 20 will be printed. Then I'll be moving temp equal to temp arrow next. So temp is over here. Then I'll be printing temp arrow data. So 30 will be printed. Then temp is moved and temp is over here. Then I'll be printing temp arrow data means 40 will be printed. So 10, 20, 30 and 40 will be printed. And then I'll be moving temp equal to temp arrow. So now temp equal to null. And that is my terminating condition. That if temp is not equal to null, we will be printing. But if temp equal to null, we will get out. So this is how entire 10, 20, 30 means entire queue is printed. Right, and if we have main like this 10, 20, 30, 40, 4 elements have been inserted, and if we display, so we know that 10, 20, 30, 40. Now if you use DQ, that means from front 10 will be deleted and this 20, 30, 40 will be printed. Alright, if we do PIP, we'll be having front and rear elements printed in this one. For example, the front is, new front is 20 and this one is 40. And last, if I print display one more time, so 20, 30, 40, because PIP will not make any change. pip will not remove any element, pip will not add any element, it will just display. So 20, 30, 40, whichever was the previous situation will be the new situation 2. All right, and the link that we have specified over here, that is nothing but my entire program on the GitHub. So you can go and refer that program for this queue implementation using linked list. So with this I conclude this topic of implementing queue using linked list. So thank you guys for being with me. In our next video we will be talking of implementing tree data structure, which will be the very first non-linear data structure. Thank you, sir.